All right, so we're going to look at our study guide. Here we go. So we have 16p2. That comes from our formula npr, which equals n factorial over n minus r factorial. So in this case, our n is 16 and our r is 2. So I would have 16 factorial over 16 minus r factorial, not question mark. Oh my goodness, sorry. 16, oh dear, n minus r. My, it must be late. Okay, let me get rid of the r. There we go. 16 minus 2 n factorial. There we go. So we would have 16 times 15 times 14 times 13 times 12, dot, 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 all the way down to 1. On the bottom, we would have 16 minus 2, which is 14. So I would have 14 factorial, or 14 times 13 times 12, dot, 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 all the way down to 1. So I can cancel 14 down to 1 and 14 down to 1. And then I'm just left with 16 times 15, which is 240. And that would be your final answer. Alrighty, on to the next one. This one is a combination. So this would be NCR, which is going to equal n factorial over n minus r factorial and then r factorial. So I have 14 factorial over 14 minus 4 factorial and then 4 factorial. All right, so 14 factorial, 14 times 13 times 12 times 11 times 10 times 9, blah, 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 all the way down to 1. Then we have 14 minus 4 is going to be 10. So 10 factorial would be 10 times 9 times 8 times 7, all the way down to 1. And then 4 factorial would be 4 times 3. Whoopsie, let's fix that. 4 times 3 times 2 times 1. Then on this one, I would cancel the 10 down to 1 and 10 down to 1. Then you could multiply what you have in the top. When I multiplied that, I got 24,024. And then in the denominator, multiply that and you get 24. Then divide, and I got 1001. That would be your final answer. Okay, how many distinguishable permutations are in the word creativity? To do this one, we have to know how many letters we have, first of all. So we're looking for how many different ways can we reorder the letters so we have unique orderings of those letters. So I have 10 letters if you count them up. So I would say 10 factorial. Then I would look for any letters I have the same. So I have 2 T's. Since there are 2 of them, I do 2 factorial. And then I have 2 I's. So again, since there are 2 of them, I do another 2 factorial. And that's all my repeated letters. So then I would simplify. And when I do that, 10 factorial, I get 3,628,800. And then 2 factorial, that's 2 times 1 times 2 times 1. Those are my two factorials. So I get 4. And then when I divide that out, I end up with 907,200. Okay. Then, how many different passwords can be created that contain 4 digits followed by 5 letters without repetition? Whoopsie, we jumped a slide there. Okay, so 4 digits, 1, 2, 3, 4. 5 letters, 1, 2, 3, 4, 5. And these, again, are digits. And these would be letters. Okay, so how many digits are there? Well, there are 10 different digits we use. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a total of 10. And so when I go to pick out whatever digit I choose first, I have 10 different choices. When I get to the next one, since it says without repetition, that means nothing can repeat. So whatever number I pick on the first one, now I can't use it anymore. Now I only have 9 choices, and so on. Then I only have 8 and then 7. Same thing for the letters. I start with 26 choices, then I only have 25, and then 24, 23, 22, and I'm set. So then all those numbers I get to multiply, and I get 39,783,744,000 like so. Or your calculator might come up with a number like this, 3.9783744 times 10 to the 10th. If you get something crazy like that on your calculator, that's fine. Where did my little slide thing go? Oh dear. Okay, well, that's all right. We will. Sorry, my thing started being a little bit silly. Okay, I can't fix the weird line through the 4 and the 4. Sorry about that. Okay, so we are just going to continue right along and go to the next one. So how many different passwords can be created that contain 6 digits followed by 2 letters if the numbers and letters can repeat? So sorry about that. My thing's being funny. Okay, so 6 digits this time, 1, 2, 3, 4, 5, 6, and 2 letters, 1, 2. And then this time we can repeat. So when I do my digits here, digits, and this one we have letters. Okay, so for my digits I have 10. The next one I still have 10 because I can repeat if I want to. So all of these I end up having 10 different options for each digit, and the letters 26 and 26. So I multiply all of those lovelies together and I get 676 million even. There we go. Or it's possible your calculator might give you 6.76 times 10 to the 8th. That's okay as well. So, awesome. Let's see if I can get this to go forward without having to do something annoying. Nope, have to do something annoying. Sorry, guys. Okay. Okay, if a coin is flipped 6 times, what is the probability of getting tails 6 times in a row? Well, this would be the probability of tails 6 times in a row. So that means I do the probability of tails times 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 the probability of tails, and I have 6. Yay. So on this one, it is multiplication between your probabilities because this is an and problem. And when we have that idea of and, it means multiply. Okay, so it's and because we flip a coin and then we flip a coin and then we flip a coin. So you see that and in there. All right, so each time we flip the coin, our flip of the coin is not affected by the previous time we flipped it. We still have the same chance we're going to get tails. So the chance I'm going to get tails is 1 out of 2 options. So heads or tails. So I'm going to, one way to get tails out of getting heads or tails. So I had 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. And you would just multiply all of those all the way across. If you wanted to write it with a few less numbers, you could say 1/2 to the 6th. But anyways, when you multiply it out, you get 1/64. All right, on to the next one. Then we have, this one we have theoretical versus experimental probability. So theoretical is what we normally calculate. This would be just coming from the information right here where it says a spinner with 8 equal parts labeled A through H. So if we only look at that and say, okay, if there are 8 equal parts and each section has its own label, what's the probability I'm going to choose H? Well, there's only one section that's labeled H out of 8 sections. Then I go to the next one. This says A or G. Here's a new word here. When we see or, that's going to mean addition. So the probability I'm going to get A or G. First of all, probability of A, well, there's only one section labeled A out of 8. And then I'm going to add, and there's only one section labeled G out of 8. And so I get 2/8, which reduces to 1/4. Then we have theoretical probability of, I'm sorry, still theoretical. Now we're going to do probability of D and G, and there's that word and, so we're going to be multiplying. It also means we are spinning twice because we spin once and get D and spin once and get G. There's no way to spin that spinner and get both in